For today, I'm going to talk about what I will call dynamic analysis of technological change. So, this is coming from the article by Adner and Kapoor, Right Tech, Wrong Time. So, this was published back in 2016 in Harvard Business Review. Now, what I will present today, and as with the other articles that you guys may have started to read about, these are extensions or expansions of the basic concept of Clayton Christensen's principle or concept about the innovator's dilemma. So you would have seen some articles that try to debunk or critique that concept. Now, this particular article intends to expand the concept further, and we'll see that in a little while. Now, the idea in brief, okay, and this is how the authors started, is that over the past 20 years, we've gotten very good at predicting whether a new major technology will supplant an older one or will replace an older one. But we are still terrible at predicting when that substitution will take place. Okay. Now, based on our understanding of the S curves and how the innovator's dilemma play out in certain industries, okay, we know that, okay, certain technologies, certain products will replace older products or older technologies, but the authors start out that as to the when will that substitution or when will that replacement take place? That is something that we're sort of aloof as of the moment. Now, the insight that they're getting is that if the new technology doesn't need a new ecosystem to support it, in other words, that product or that technology, if it's new, will still work within the old context, will still work with the old environment. If, as they say, is essentially plug and play, then the adoption to the new technology will be swift. It will be quick. Okay? And this is pretty much what we would see based on the basic idea by Clay Christensen. Now, if the other complements are needed, so there's a new technology, but you also need other products that would play in tandem with the new technology, then the substitution would be slow, it would be delayed, and it will only happen until those challenges are resolved, meaning those complements are provided, they're easily accessible by everybody else, okay? And we start to see that the timing of the substitution for this new technology tends to be dragged along, okay? It won't happen immediately. Now, change even takes longer when the old technology this time around gets a boost from improvements in its own ecosystem. So just when you think that the old technology has been predicted to die out or to become obsolete, and then all of a sudden there is some sort of an impetus or even credible motivation to develop that old technology further, and then it actually improves well, the switch, the change to the old technology, sorry, the change to the new technology will not happen immediately. It will take much, much longer. So, what's the implication here? Were two things. For startups, for those who are technology ventures that supposedly try to work on the new technologies, they need to consider not just when their innovation will be viable, but also what external bottlenecks will arise. So it's not just about the technology. They also need to look at the circumstances around that technology and whether those circumstances would be favorable to actually pushing forward with that particular technology. And secondly, if you're looking at the incumbents or those who've been in that environment or in that industry for some time, well, they should look at using this transition period, okay, meaning that they know that at some point in time, we're going to move from the old to the new. In between that period, okay, between the old and the new, they should try to figure out a strategy for long-term survival. So that would mean how much of the old they will continue to use, and at what point do they start using the new. And then even further, like the new might later on be supplanted by the newer new. Okay, and that's something that the incumbents, those who are already working in that particular environment or industry, would need to consider. So let's start off with this idea, and you're probably familiar with these S curves. Okay, you've probably seen some basic form of the S curves, and the one in blue would represent the old technology curve, and the one in red would represent the new technology curve. Now, the idea here is that there are additional curves that you tend to see. You'd see some dotted line curves, right? The blue dash curve and the red dotted curve. Okay. And what does this mean really? Well, there are two incremental ideas that's added to the basic notion of the S curves. Okay. And the first thing is that can the old technology improve further? Okay. And the second idea, can the new technology be used or exploited right away? So, without these two questions, our view of the S curve and how technological change happens, that seems to be a very static notion. Initially, as an introduction to how technology changes, that's a good start. The S curve is pretty much a very basic concept. But then once we start to unpack and stretch the ideas and perhaps start questioning the assumptions behind the original concept, then we get to see okay, it's not just a static view or it's not a static path. Okay, there could be some extensions or expansion of the idea. Okay, and we're seeing two possibilities here, two possible extensions or expansions of the idea. Well, the first one is, what if the old technology, we're thinking that the old technology will actually die and go obsolete? What if it can improve further? And the second idea is that as regards the new technology, well, the new technology already exists, but can they be used right away, or will further development be still necessary before it can be viable or it can be used, even at a commercial level? So these are expansions to the original idea. And you can even say that, okay, this could be like uh, questioning the basic assumptions of the S curve. Well, you'll notice that there are 4 points here, four intersection points based on the expansion of the assumptions. Well, the first point, point A, the authors call this point creative destruction. And this is the original point of intersection with the old S curve idea. And what happens in creative destruction? Well, we know that this is the classic substitution. And obviously the fastest, because this would be something that, okay, looking at the other 3 points, which we'll discuss in a while, they occur earlier in time. So the substitution, the switch from the old to the new, happens earlier. Okay, and they take place when the new technology is ready to go. You can start capitalizing on the new technology, and the old technology can no longer be improved, meaning there's so much that you can do already with that old technology that it follows already a static path. That's the basic point. But now let's go to the other 3 points. So let's start with point B, which the authors call robust coexistence. And you can see that's the intersection of the new technology and the supposed new path of the old technology, okay, by the dashed blue lines. This means that the old technology can still be improved further. So, what does this mean? What does point B really mean? Well, if the new technology is still compatible with the old existing ecosystem, and here's the clincher, the old technology's ecosystem can be significantly improved, then substitution takes place relatively later and at a higher performance level. Okay. So technology or the switch to the new technology won't happen right away. It will be further back, okay? It will be further later, okay? It won't happen right away. But when that happens, it's possible that your substitution point, okay, would occur when the performance is higher, okay? And that's fine, okay? You're still stretching the usefulness of the old technology, and the new technology is somewhat compatible with the old technology. Okay, you can make that replacement later on at an even higher performance level, and you call that point the point called robust coexistence. Okay, now what about point C? Now, point C, the authors call this point as the illusion of resilience. Now, why is that so? Well, here, the new technology isn't really delivering on the hype that it's supposed to be delivering, right? The new technology still needs to be improved further. Okay, it needs considerable development, and if that happens, okay, and if that happens, and even if the old technology is static, obsolete, about to die, then there's nothing much we can really do about that, right? All you can do is really wait for the new technology to be developed even further. So the point wherein substitution would happen would also happen much later. Okay. But the thing there is that performance would have been sacrificed. You will not be able to improve much in terms of your performance because all you're doing at this point is you're waiting. You're waiting for the new technology to actually be viable. You're waiting for the new technology to actually be usable. Whereas the old technology, there's nothing much you can do with the old technology. You're just letting the old technology drag along. Okay. And there are instances where this can happen. Okay. Now, for the last point, point D, you call this point robust resilience. Okay. Robust resilience. So this is, in a way, a very hypothetical point because now the authors are looking at the intersection of two curves that are not part of the original construction of the theory. And what does this point tell us? Okay, well, if the new technology's ecosystem needs considerable development, okay, so it's not living up to its reputation right away, and the old technology can still be improved, okay, then substitution can happen much, much, much later. Okay. And the reason why it's called robust resilience is because you're not switching right away to the new technology and you're trying to extract as much value as you can from the old technology as far as improvements go. So, in a way, you're holding things out, but the old technology can still be improved. So, okay, you still really make do with the old technology and then some more while you're waiting for that new technology to ripen, perhaps. And then once that happens, then that's the time that you can make that switch. Okay? Now, that's how it works. That's the interplay between the old and the new. And notice that the authors are using the term ecosystems. They're not talking about a single product or a single product line. Okay, they're talking about combinations of old technologies, okay, within the old technology paradigm and the new technology within the new technology paradigm. Okay. There could be complementary products in the old technology. There could be complementary products in the new technology. Okay. But loosely speaking, we'll just call them old technology and new technology. So the idea here is that the stretches, the shifts of the curves, or the curve that will take the dashed path or the dotted path, that would really depend on how much stretch you can really make use for the old technology and how quickly you can adopt, okay, and capitalize and exploit the new technology. Now, what are the implications for actions? Well, in this case, the authors recommend that we ask two things, two questions. Okay. Which of the 4 points is your industry in? Now that you know that there's that possibility for the old technology to be improved further, and the possibility that the new technology may not be viable as soon as you think it would be, now, which of the 4 points would your industry be in? And later on, the authors tried to present these 4 points into 4 quadrants. Okay. And the second question is what are the implications for our resource allocation and other strategic choices? So, depending on which point you find yourselves in, okay, there are complications, there are consequences that would help determine the path that you would choose in terms of adoption of technologies, whether will you still keep on using your old technology, or will you ask your company, your people to switch to the new technology? And that would depend on which point you find yourselves in. Okay. So, and here's an example of the quadrants or the 4 points. Okay. The X dimension or the horizontal dimension talks about the ecosystem extension opportunity for the old technology. Okay. And the Y dimension or the vertical dimension talks about the ecosystem emergence challenge for the new technology. Okay. So if you go higher, okay, I mean, if you go up, okay, you'll notice that this means that the new technology cannot be capitalized or exploited immediately. Whereas if you go lower, okay, lower according to the y-axis, this would mean that the new technology can be adopted right away. Whereas if you move from left to right, the ones in the right would tell you that the old technology can still be improved, whereas the ones in the left would be the ones that would tell you that the old technology can no longer be improved. Okay, and if you've noticed, the one underneath, okay, the lower half, quadrant one and quadrant two, at least in this description, these would be the examples that Clayton Christensen actually talked about. Okay, so in a sense, he was really looking at, uh, in reference to Clayton Christensen, he wasn't really looking at the idea that adopting new technology would take some time. He knew that there is going to be a level of disruption. Disruption meaning that there is going to be a shift from the old to the new. Okay? And there's something disruptive about that. But even the fact of the new itself can take some time. Okay. And because it can take some time, then the eventual time for adoption would also take some time. And this is something that I guess at that time when Clayton Christensen was looking at it, he wasn't really concerned about that. He was trying to look for an apparatus that is quite flexible for everyone's appreciation. But nevertheless, now you can see that if you start to expand the idea, if you start to remove some of the assumptions that Clayton Christensen had in the beginning, then you have a completely different landscape on how you should address technological change. Okay, and this is where you see the upper half of this image. Okay, the idea of resilience. Okay, the idea of resilience because the new technology isn't ready for use, so to speak. So you're trying to make do with the old, but you know at some point in time you will have to use the new. Okay, so that's the idea why they wanted to use the term resilience, right? You're still using the old technology. I wouldn't really want to say resistance, right? I mean, at some point in time, the assumption here is that the users, the leaders understand that the new technology will eventually supplant the old technology. So it's really just a matter of stretching or holding out until the new technology is ripe for the taking, is already ready for actual use. And we can see some cases that really belong to the upper half of this image. Now, so conclusion, technological change is not one dimensional, okay, but it's dynamic. And now we see the interaction with the old technology and the new technology. We also see that it has to be an ecosystem mindset. We realize that certain products would rely on other products, either for its sustainability or, in the absence of those other products, its obsolescence. So it's dynamic. Okay, we know that old technology can still be improved on, which stretches the life of the old technology. Okay, or we can look at new technology not being ready yet, but somehow in an anticipatory way, we know that there's something more to to the new technology. We know it will come. It's not just going to be useful now. And the idea there is that, well, the S curve in its original construction, it's not completely wrong. Okay. If you've noticed how the authors presented the expansion of the idea, it still follows the S curve. Okay. Slow start, and then it starts to peak right away and then has a plateau. Okay. You also see that in the newer construction by these two authors. Okay, so the S curves aren't really wrong. Okay, and the older way of understanding and appreciating the S curves is that they're easier to analyze. Okay, and they're easier to analyze when you're only looking at one thing. If the analysis is static, okay, but the implications drawn are sure to be limited. And we're starting to see the reasons why the static analysis of technological change is limited. Okay? There are complementary products, there are other factors that we need to consider, and thereby, I mean, making the analysis dynamic. And here we have to understand that there are factors that are beyond the factors of one's own technology. So the idea with dynamic analysis is that we have to combine both groups. Okay, you have to look at the factors of the own technology, but you also have to look at external factors, factors of the new technology, factors of the industry, okay, factors of complementary products. Okay, and these are things that are important in determining how technological change will happen. Okay, so we know for a fact that the behavior follows an S curve. The thing there is that we don't know the size, the length, okay, and at which intersection points the two curves will happen. Okay? But if we have a better understanding of all the factors involved, maybe we'll have a much more accurate prediction on when the substitution would happen, which is why the authors have been, I guess, comfortable with presenting with four quadrants just to give you some sort of wiggle room, perhaps, but enough differentiation to know depending on the characteristic of the old technology and the new technology. And lastly, the idea here is that if you really want to predict the future, as they say, the best way to predict the future is to create it. And of course, the reason why we try to have some sort of 10,000-foot view of technological change was maybe we're just an observer. We're not the ones really in the forefront of technological change. But these rules, these principles, these concepts don't really apply to those who are actually doing the technology or inventing the technology, right? They have further control of what's going to happen, particularly the inventors, the innovators. And in an instinctive way, they know that if they do the right things well, then the results, the benefits from whatever it is that they're developing would come sooner than later. And those situations, that's really the best way to predict the future. Okay. And this quote, it has many references. They consider this to be a quote from Abraham Lincoln. Others say that this was a quote from Peter Drucker. But nevertheless, whoever said this, there's really no issue. And somehow this quote makes sense. So with that, I end my presentation on technological change. Okay, and I hope you've been able to get a finer appreciation of the S curves and how technologies, the old and the new, interact with one another in light of factors that were not considered in the earlier analysis. With that, I open the floor for questions. Do you have any questions for me about this particular topic? Yeah, go ahead.
So regarding dun sa S-curve, parang based on what you said, is there like in the graph itself, di ba, parang pa-S siya talaga. So is there a time where it's best to actually look for a new technology? For example, pag nandun na siya sa medyo like in the complete stage, pag alam mong medyo nag-scale ka na, is that the time to actually look for another technology to invest in or to do something else? Parang ganun. Parang dun, yun, I'm not sure if there's like a right quest a right answer for it. Pero parang ganun ko siya nakikita na pag medyo tapos ka na dun sa ginagawa mo before na technology, you look for a new thing. Parang ganun. Or is it like a process na kailangan mo lang talaga siya gawin every time?
Okay, that's actually a good question, right? So if I were to paraphrase it, the question is, as I am traversing the curve, at what point along the curve should I consider looking at new technologies, or do I stick to the current curve, right? And that's a pretty difficult question, right? I'm sure nobody has had a very good way of determining at what point do you start looking at new technologies, right? So there's no mathematically correct answer to that. Okay. The thing there is that, well, for one, you do know that technologies follow the S curve pattern. So if you're starting to notice that the old technology is scaling up, then it can be one of two things later on. It will continue to scale up, or it will start to plateau. It will just be one of two. So the thing there is that the question that you'll probably ask yourself is, okay, I'm already scaling up. I'm sure I'm scaling up. Now, you probably would want to ask yourself, in light of the article, is the old technology still improvable? Okay, can you still improve on the old technology? Okay, and I'm sure there will be other things that you can consider about the old technology that is still improvable. If there's still a lot of things that can be improved in the old technology, then perhaps you can go and continue with your bet with the old technology. But if you start to look at the technology landscape you're in, and you started to determine that, oh, okay, there's nothing more to improve here, maybe just one or two things, few of them, but not that many, then you may start to look at newer technologies because there's nothing else to improve. Okay, so I guess that's how you look at it. But then again, even if I tell you this, it's you don't know what you don't know, right? Sometimes, and we've seen this in the history of humanity, just when you think that you have tried to predict everything down, then something weirdly happens. A black swan event, or what Donald Rumsfeld would have said, the unknown unknowns, right? These things can happen. Which is why I think to end how I answer that question is the leaders, the ones in charge of organizations, the important skill that's necessary for them with regard to navigating technological change is that they need to have good sense making. They need to properly make sense of the situation. They can understand the external environment very well, as well as the internal environment. And based on the information that this leader can capture, then makes that decision whether to stay on with whatever technology that they find themselves in, or they start looking for the new technology that would help them propel further moving forward.
Thank you, sir.
Are there any other questions? That was a good question, actually. Okay.